Hello and welcome to another alternative solution. And this is where I have already made a video solution for this question, but I've noticed that other people's answers, and not least White Rose Math's answer, looks a bit different. So I thought I would post an alternative to illustrate how it is that I think they arrived at their solution, which helps me make 2 points. One, that bar models, especially the more challenging the question gets, the bar models will often look different, and that's because they really are individual to the person drawing them, and you have to draw what makes sense to you, and we might approach things from different angles, which is what has happened in this case. But also that it can be, and the whole reason I make these videos is it can be incredibly difficult to follow what someone else was thinking when all you see is their completed solution. And so, and sometimes it can cause just as much confusion as the original question. I mean, it said this is an excellent solution, and they've done it using their great new tool, which I don't use because I like to replicate using pen and paper, but this is actually one of the better tools that I have seen for doing bar models. But anyway, let's crack on and see if I can explain how they have approached this problem, which is basically the other way around to how I did it. Anyway, some adults and children are in a museum. 2/5 of the number of adults is twice the number of children. 24 more children enter the museum. 35 adults leave the museum, and the ratio of adults to children is now 5:2. The question we are asked is how many adults were in the museum at the start? Okay. Right, well, clearly I am going to start by drawing a bar, as they've done here, for the adults and for the children. So we've got adults and we've got children. And what I'm going to do is take my leave from here, and we realize that we're going to be dealing in fifths. So I am going to draw, and very badly draw, but as I said, I do like to replicate pen and paper, and I'm just as bad on pen and paper as I am here. So 1, 2, 3, 4, 5, and believe it or not, those are all supposed to be the same size. Okay, and what have I got? 2/5 of the number of adults is twice the number of children. Okay, so this is 2/5 of the number of adults is twice the number of children. Okay, so that means that the children have one of these parts, one of these fifths from up here. So that's a convoluted way of telling us, it's quite fun, that the original ratio is 5:1. Okay, so that's what we have at the beginning. So I have got that information there. And what I also want to put in here is this is the start, okay, because I know I'm going to be messing around with these bars, and this is my question. I need to see how I can figure that out. This is really terrible. Shall I see if I can fix that? There we go. I'll probably make it worse. That's a bit better. There we go. Okay. So how do we think they've done it? Okay, well, what happens? 24 more children enter the museum. Okay, I'm just going to add 24 here for the moment. And 35 adults leave the museum. So 35 leave. Okay, so what we want to do, remember, these are equal parts. And we want to take away this 35 in a way that we can keep parts the same size, or maintain having equal size parts, because that's really important to how we're going to make our calculations. And so what they have done is to distribute this loss of 35 over the 5 parts. So we have 35. If we divide that by 5, we get 7. And they have distributed this loss of 7 over the 5 parts. Okay, so we're sort of shaving off 7 from each of the original parts. So that's 7, 7, 7. So this now reflects the loss of the 35 children. And what we could imagine really then is that, and I don't need to do this obviously, but it's just to make it really clear, these are the new parts. Okay, and again, these are all supposed to be the same size. So these pink parts are all the same size, and they are the original parts minus 7. Okay, now again, if we're doing that to these parts, we want to maintain the size of the parts. We have to do the same to this block here. Okay, so we're going to have to shave off that 7. Okay, all right, and this, and I said I don't need to do this, but I'm just emphasizing the fact that these are all equal parts. So we have now reflected this loss of 35. But so we've done that, but 24 more children enter the museum and our end ratio is 5:2. Well, what we have here now is 1, 2, 3, 4, 5. We still have 5 parts here. They're smaller, but we've still got 5 parts. We need 2 parts here, and they of course need to be the same size. So we're going to add another one. Okay, that's the same size, and I'm just double drawing it because I've done that to all of the others. Now I don't need to draw in the 7 because these 7 children never existed. It's just, but if I did, you could see that that's just the same as one of these. Okay, but I don't draw it here because I don't need to, and because these 7 children, they don't exist, which is why, so this now is my 5:2, but it doesn't look like it, okay, because of this gap of 7 here. All right, and unless you understand what's going on, then you're thinking, wow, okay, how does that reflect the end situation? Okay, so where are we? We've lost the 35 children, and we now have the end scenario reflected in our 5:2. Now, what's happened to these 7 children? Because we didn't lose any children from the museum, hopefully not, okay? But we haven't lost any as far as we know. So they must be somewhere. And they must be in this bit that we have added here. So we have the 7 children must be in here, as must be the 24 children who came into the museum. Okay, so here we have the 7 plus 24, okay, into this part here. And this is the calculation that we have here. Okay, and that then gives us 31. All right, so now we can say that this is 31. And that's bingo in terms of bar modeling, because we now have a value for one of our units, our equal parts. So here we go, 31. Everything then, all of these have a value of 31. Okay, and that's what they have here. And then we've got all the information we need then to work out what we had at the start. So what they've done here is that 31 add 7. So they've calculated the size of each original part, and that gives 38. And then we have 38 times 5, which equals 190. So that is our answer. And of course, what we could have done is 31 times 5, excuse me, 31 times 5, which would give us 155, and then add in the 35, which again obviously would give us 190. So that's our answer, and that's how I believe White Rose Maths went about it. If you go back and look at my video, I just went about it the other way. I distributed the gain of the 24 children, okay, I distributed that across the two parts in the end of the children, and then drew the adults model in order to reflect that. So I just did it the other way around. So it was very much the same thinking in terms of distributing the loss or distributing the gain over the multiple parts in order so that you maintain something that you can work with, these equal sized parts that you can work with. Anyway, I hope that helps, and hope you tune in next time for another solution to White Rose Maths tricky problems.